as assignment is in the diagram below. P, Q, and R are points on the circle center O. If OPQ is equals to what? If 38 degree. If OPQ equals to 38 degree, what is the size of PRQ? Now let me quickly draw the diagram on the board. This is the circle. We have this. Okay. So we have this as O. This is P, Q, and R. And this angle here is 38. There is one thing about this question. Now to solve this, I want to calculate this angle PRQ. This angle PRQ is the angle that is on the circumference of the circle. And for me now to get this angle, I must first get this angle. I mean POQ. You know, if one is able to get this angle POQ, one will now divide it by 2 to get this. And the theorem is angle at center twice angle at circumference. But I cannot easily just get this one without first getting this. I need to get this angle. But looking at the diagram, we all know that this OP and OQ are the same. Because they are both what? Radar. Now, so if line OP is equals to line OQ, then it means that if OP is equals to line OQ, then it means that OPQ is equals to PQO or OQP, and that is what 38 degrees. And the reason is not perfect. We have base angles of isosceles triangle. Because it's an isosceles triangle. This is radius and this is radius. Now, so we now have this as this one is 38. We can easily calculate this angle. This angle, we can say POQ plus 38 is equals to 180. And the reason is sum of angles in a triangle. So adding these two angles together, we have 76. Abi? Yes. So if it is 76, one can now get POQ as 180 minus 76, and that is what? 104. So what? It's 76. And when you now subtract 76 from that, that's 104, right? Yes. So POQ equals to 104. So if this angle is 104, now to calculate this angle that is at circumference is going to be PRQ is equals to POQ all over 2. POQ all over 2. And the reason is angle at center twice angle at circumference. Angle at circumference. Then POQ is 104. PRQ is equals to, now I want to use this angle POQ, and this POQ is 104 degree all over 2, and the answer is 52. Is that the answer? Yes, sir. Now let me do the second one. The second diagram is this. Then we have this. Okay. What is the letter here? P O R S. This angle, which angle is given here? Okay, this angle is 150. You know, in this type of diagram, this is a quadrilateral, but it is not a cyclic quadrilateral, as the fourth vertex does not touch the circumference of the circle. But to get this thing, I want to get this PSR, this angle PSR. But I told you something yesterday that both angle at circumference and angle at center must not be in the same sector. Okay, this is a sector. This is a sector now. So I need to first get this. And you know, this POR, this one is obtuse POR, while this one is reflex POR. So the two are not the same. So let me first get reflex POR. Reflex POR plus 150 equals to 360. And what is the reason? Sum of angles at a point. Sum of angles at a point. Now we have POR. POR is now equals to 360 degree minus 150 degree. And what do we have? 210. That's 210. So this angle here is 210 degree. Now for me now to calculate PSR. So this angle at center is 210, and I want to calculate this angle PSR. PSR is now equals to 210 degree all over 2. Because reverse is the case. So, and the reason is angle at center twice angle at circumference. Angle at circumference. And what will be the answer? 105 degree. So that is how to calculate. Because if you have a question like this in the objective, and you have 150 and you divide this 150 by 2 to get this at 75, it's wrong. It's wrong. So don't use that method. Both angle at center and angle at circumference must not be in the same sector. Must not be in the same sector. Now let us continue with the next theorem. And we have this. This is theorem. Angles in the same segment of a circle are equal. Now look at this theorem. This is the third one, because yesterday I gave you two theorems. The first one is when you draw a line from the center of the circle, it is perpendicular to the chord and bisect theta. Yeah. So the other one is angle at center twice angle at what? Circumference. So this is the third one. Angles in the same segment of the circle are equal. Now, like I said yesterday, that all these theorems depend on angle at center twice angle at circumference. Now let me explain what I mean by that. Now we have a circle. This is a circle. This is a circle. Now we have this as center. Now let me draw this. We have this. Okay. We have this. We have this. We also have this. Now, this is what is called angle in the same segment. Then I want to explain the reason why they are equal. Now this is O. This is O. Let's call this one A, B, C, and D. Now I want to label these as X or X1. Let me label these as X1. If this one is X1. Now to this diagram A, B, D. This is angle at circumference, while this one is angle at center. If I clean this line now, then we have this diagram. This is angle at circumference, while this one is angle at center. Now I want to get this angle, or let me say obtuse AOD. Obtuse AOD is equals to 2x1. It's 2x1. And what is the reason? Angle at center twice angle at circumference. Okay. Then likewise, when you have this as 2x, when you have this one as 2x1. Okay, let me also label this as y1. I label this one as x1, then I also label this one as y1. Now to this diagram now, when you have ACD, this is angle at circumference, while this one is angle at what? Center. So I can still say, okay, obtuse AOD is now equals to 2y1. That is times 2 of this will give you AOD. So the same reason, angle at center twice angle at circumference. And don't forget that both AOD that we have in the two are equal. So we can take 2x1 and say it is now equals to 2y1. So if 2 cancel 2, what is left is x1 is equals to y1. And that shows that the angles in the same segment are equal. So what I used to prove this is still that of angle at center, twice angle at circumference. But don't forget that you must have that figure 8 before you can use angle in the same segment. And that of the figure 8 that I explained yesterday is completely different from this one. Now when you have something like this, it is T8. This one is T figure 8, but this one is not angle in the same segment, as the fourth vertex here does not touch the circumference of the circle. You can only use this one as angle at circumference twice angle, angle at center twice angle at circumference. If this one is 20, this one is going to be what? 40. But when you have angle in the same segment, the two angles, the two vertices, it's like the two arms must be on the circumference, while the two legs also must be on the circumference. I can still form another one by doing this. So we now have angle in the same segment. But I cannot say this one is equal to this, no. But this one is equal to this angle. Is that taken? Now, there's another theorem, because I want to merge the two theorems together before giving you examples. Okay. Now, the next theorem is this. The next theorem is this. Let me write it on the board. Now the next theorem is this theorem. The angle in a semicircle is a right angle. Is a right angle. Now before it escapes my mind, I've been directed to inform you that there will be no lesson tomorrow. And the angle in a semicircle is a right angle. I will still use that angle in the angle at center twice angle at circumference to prove this. Look at this. This is a circle. This is a circle. This is a circle. Then we have this center. Now the theorem is angle in the semicircle is what? It's 90 degrees. It's a right angle. Now let's have this as this. Okay. This is angle at circumference. And I want to prove the reason why this angle is 90 degrees. I will still use that angle at center twice angle at circumference. Let me label this as ABC. And why this one is O? That center is O. It means that for me now to get ABC, ABC is equal to angle at center is 180. That is sum of angles on a straight line. 180 degrees all over 2. Reason, angle at center twice angle at circumference. Now, we now have this as what? 90 degrees. So that is how to do it. But before you can use this theorem, angle in a semicircle is a right angle. You must have a diameter. You must have a diameter, because if you have a circle like this, if you have a circle, then this is the center. You now have this. You cannot say that this angle is 90 degrees, not. Because this line is not a diameter. And even when you have a diameter, and you have this line here, the two lines must meet to give you an angle. You cannot just have it as this and say, okay, it is now, okay, when you have something like this, you cannot call this one 90 degrees. It is not 90. Okay? But when you now join this to this, then this angle will now give you 90 degrees. Is that taken? Okay, now let us try some questions. Now, example. Find the lettered angles in each of the following. Find the lettered angles in each of the following. Find the lettered angles in each of the following. Find the lettered angles in each of the following. Full stop. Where a point O is given, comma, it is the center of the circle. Where a point O is given, comma, it is the center of the circle. Full stop. Now let us have the first diagram. The first diagram is this. Is this one right? So now we have this. Now we have this point. The first value here is A. We have this as 40. This one is B. Then we have this as C. Then this one is 32. This is angle A, this is 40. Now, look at this diagram. Look at this diagram. I have explained that before you can use angle in the same segment, that you must have that 8. And all the 4 vertices must be on the circumference. Let us now get that. If it is possible for one to clean this, look at it, let me just clean this line. When you clean this line, you can see that 8 clearly here. Can you see that 8? Aha. So these are the 2 arms that we have, while this one are the 2 legs. I'm talking of this. You cannot take this as angle again, 32. You can see that I've already cleaned, the line that bound that angle. So you cannot call this angle 32 again. So this is the angle that I'm referring to, this and this. Okay, now, what is the size of that A? It's 40 degree. 40 degree, same segment. There's nothing like saying A is equals to C, no. But this angle here is equals to this angle. Is equals to this angle. This angle is equals to this angle. In fact, this one, because I need to draw the diagram back to have this equals to C. Now A is equals to 40 degree, and the reason is same segment. Same segment. The reason is what? Same segment. Then after that, let me now add the diagram back. The full diagram back. So with this, if you now clean this, you still have that 8. Look at the 8 that I'm talking about. Look at the 8. Can you see that 8? B? And what is that B? B is what? It's also 40 degree and the same what? Reason. B is 40 degree. Well, okay, what is now C?
32.
C is 32. So this is how to solve the question. Is that clear? Okay. Now the second one. The second diagram is this. Second diagram is this. Now we have this as a diameter. This is a diameter O. We have this. This is G. This is 115. This is E. Now, this is the diagram. This is the diagram. Now, like I said earlier, that before you can use angle in a semicircle equals to right angle, you must have a diameter. The line must pass through the center. This is a diameter. From the starting point of this diameter, we have a line here. We have this one. But this one is, it does not, has nothing to do with the end point of this diameter. But look at this. This is the starting point, we have a line, and this is the end point, we have another line, and the two lines are joined together. So it means that this angle E is what? 90 degrees. But I cannot take this, I cannot say because this is the starting point here. This is the starting point of that diameter, and you have a line, and the line is joined to this one, and you now want to take this as 90. No. In fact, from this point here now, if I draw a line from here to this point, the angle here is 90 again. Am I communicating? Okay, look at this. From here, if you draw a line and you stop here, and you now join this point to this one, the angle is now 90. Are you with me? Yes. So this angle here is 90 degrees. And what is the reason? Angle in a semicircle. Angle in a semicircle. Angle in a semicircle. That is 90 degrees. E is 90 degrees. Now, for me now to get G, you must always look for that 8 that we have in the diagram, that figure 8 that we have in the diagram. In fact, I can clean all this for you now to see that 8 clearly. Can you see the 8? This angle here is equals to this angle, while this D is equals to which angle? D is equals to 115 degrees. The reason is angle in the same segment. The same reason. The same reason. So that is how to solve the question. Now, do you have any question? Is there any question? We have a question. Okay.
D equals to 115.
It's not
the same reason.
the same
Reason. Angle in the semicircle.
Sorry, the reason is it's same segment. Same segment. Same segment, please. Angle in the same segment. That's the reason. Not angle in the semicircle. Same segment. B is a diameter. AB is a diameter of semicircle. AB is a diameter of semicircle ABCD. Of semicircle ABCD. Full stop. If ABD is equals to 16 degrees, calculate BCD. Calculate BCD. Now let me still draw the diagram on the board. Now this is the diagram. Now we have this as diameter. This is 16 degrees. This is B, C, D, and this is A. Now, look at what we have on the board. We want to find the angle BCD. Now, BA is what? What's the line? That line BA is the diameter. Is the diameter. You know that if I join A to D, this angle will be what? 90 degrees. But I don't want to do that. Okay? I want to join this to this. So that it will give me that 8. Can you now see that 8? This is 8. If I clean this line, you can see this 8 now. Okay? Which angle is equals to 16? Use 3 letters, please. B, B, C, D. No? B, A, D. Is 16. ACD. This angle is equals to 16. Same segment, right? Same segment. Why this angle 2 is equals to this? Is that taken? So it is ACD. If you now say BCD, you are referring to the whole angle. Is that taken? So let me now join this 2 points together again. So ABD, which is 16, is equals to ACD or DCA. Are you with me now? So ACD, which is equals to what? 16 degrees. The reason is what? Same segment. The reason is same segment. So this angle here is 16 degrees. Then, who can tell me the size of this angle?
90.
It's 90 degrees. And what is the reason? Angle in a semicircle. So, and please, I want someone to use 3 letters to name that angle 90.
BCA
Or
ACD.
ACD or BCA. BCA is equals to 90 degrees. Reason is angle in a semicircle. Angle in a semicircle, which is what? 90 degrees. So in order to get BCD, BCD is what? BCD is now equals to 90 plus 16. There is no reason here because we are just adding the 2 angles together. And answer is what? 106. That's it. It has diameter because it passes through the center hole. This is I, this is J, this is O, and this is 65 degrees. Now let me just give you 5 minutes to do this. That 5 minutes is too much for that. It's what you can just finish within 2 minutes. Marshall will come and solve the question on the board. Angle in a semicircle. Okay. Is that the answer? Yes. Let's clap for him. So I here is equals to 65. That is what is called same segment. Then addition of these 2 will give us 90. Angle in a semicircle. Please don't forget that this is the starting point of this line diameter. You have a line here. This is the end point. You also have another line. And the 2 lines now meet at a point. So the angle that the 2 lines will outform is what? 90 degrees. That is why I plus J is 90. Is that taken? Yes, sir. Now let me give. If angle DAC, if DAC is written on the board equals 27, comma, angle ABD equals to 54 degrees, and angle ACB is equals to 63 degrees, find 1. Angle CAB and 2. Angle AEB. Angle AEB. Now let us now have the diagram of this question. We have this is the diagram. This is the diagram. C, B, A. Now, in this question, in this diagram, there's nothing like center. So don't make attempt to use angle in a semicircle equals 90 degrees. If you call this angle 90 degrees or you call this one 90 degrees, you are wrong. There's no center. You know, don't forget that the line must pass through the center before you can use that angle in a semicircle equals 90 degrees. So that is that. And also, if you have a diagram like this, you must first read the question. It is possible to have a value inside the question that will not be inside the diagram. So you need to read and make sure that all the values that you have in the diagram and the questions are in the diagram. Is that taken? Okay. Now, so that is the first one. Then number 2. Number 2 question. In the diagram below, comma, P, capital letter P, comma Q, capital letter P, comma Q, comma R, are points, comma Q, comma R, are points on the circle. A point on the circle with center O, full stop. T is a point outside the circle. T, capital letter T is a point outside the circle, full stop. Angle STR is equals to angle MRS, which is equals to 32 degrees. Angle QPR equals 47 degrees, and QMST is a straight line. Full stop. Find angle PQM and angle SRT. Okay, now let me draw the diagram on the board. We have a center here. Now this line PR passes through the center. This is O. We have this as P, R. Then we also have this line. P, Q. Then we have this. We also have this. T, S. These 2 points are joined together. There's a point here, M. This is 32. This is 32. This is 47. And this is 32. So, this is the diagram. You are looking for PQM. PQM. This is the angle. Then you are looking for SRT. SRT. So that is what we are looking for in the question. Good day.
Thank you, sir.
You're welcome.